Hi there, it's Professor Monty. Let's look at completing the square to graph quadratics. In other words, parabolas. All right, so the problems here just say complete the square and then graph. Well, I've got f of x equals x squared plus 6x plus 3. I want to complete the square because I want to use my idea of reflections translations to graph these. All right, so I'll leave the f of x right here. You can change that to y if you want to. But I'm just looking at these two terms right now. I want to complete the square with those. Don't worry about the 3 right now. But I've got this x squared plus 6x. Remember, to complete the square, let's go back to what we learned previously. If this is just a 1x squared, I take half of this and square it. So I'm going to go 6. I take half of that and I square it. Well, that's 3 squared, which is 9. I have to add a 9 here to make that a perfect square. What we used to do in the past, we'd add 9 to this side and add 9 to this side. We don't want to do that now because I just want f of x. So another way to get around that is when I add 9, I also subtract 9 because that's really adding 0. I'm not changing anything. And now I'll be okay. The plus 3 is still here. But now I'm looking at this piece right here. And notice that factors into x plus 3, x plus 3. We set it up that way so it'd be a perfect square. This side's going to be minus 6. But that's x plus 3 squared minus 6. And that's what I have. So I've completed the square here. Remember, it's a parabola because I have the x squared. The plus 3 inside means I go left 3. The minus 6 on the outside means I go down 6. And so my vertex is going to be negative 3, negative 6. Sometimes I tell my students, just change that side and keep that side. But since we're going left, I'm going to go to negative 3 and I'm going to go down, so I'm going to negative 6. So when I graph this, I'm at negative 3, negative 6. I'm down here someplace. Notice that's going to be my y-intercept. If x equals 0, y is going to equal 3. So I know it's coming up here to about 3. There's 0, 3. Here's negative 3, negative 6. And then I can just graph my parabola. Looks something like that. All right. This one's a little bit hard because I've got that 2. Remember, I'm just looking at this piece right now. The problem is I have that 2, so I can't just take half of that and square it. What I have to do is I have to factor the 2 out. So I'm going to factor out the 2. It'll leave me with x squared minus 4x. And I still have this plus 11 out here. But I want to add something there to make it a perfect square. Well, again, I take half of that number and square it. So what I'm going to do is I'm going to take half of this and square it. That's the number I'm going to add. So negative 2 squared, which is 4, I'm going to add 4. So it's going to look like this. X squared minus 4x plus 4. But here's the problem. I didn't really just add 4. What I really added was 2 times 4. That's an 8. So I really added 8. So to counteract that, I have to subtract 8. And then I still have this plus 11 out here. So it's kind of tricky when you have this number here. If I multiplied all this out, I'd see that it's going to simplify to that when I combine my terms. But it's 2 times 4, so it's plus 8. So I have to minus 8 to get rid of that, essentially. So now what I have, and notice this in here factors into x minus 2, x minus 2, which is x minus 2 squared. And then the negative 8 plus 11 plus 3. Again, this time it's a minus, so I go right 2 and up 3. So this is up, this is right. So my vertex up 2, right 3 is 2, 3. Right 2, up 3, that's my vertex. It was positive, so it still opens up. Notice if x is 0, y is 11. So it's going to go through here at 0, 11. That's my y-intercept. So there's my graph. Got my vertex, got my y-intercept. I kind of missed my y-intercept, but you could move it up so it actually hits. That wasn't a very good graph of it, but that's how I can complete the square in quadratics so that I can graph using that idea. This is not my favorite way to graph these. These could get really ugly. If this was an odd number when I did that, then taking half and square is a fraction that I have to add and subtract to that side. It's a mess. So I've got another way of doing this using x equals negative b over 2a. I'll link that video to the end of this. If you're having trouble with these translations that I did, I've got another video called Graphing Quadratic Equations using translations and reflections you may want to refer to. But if I'm in this form, I don't do it this way. Your teacher may want you to do it this way, and then you have to. But if it's in this form and it's not already set up nicely, if it's in this form, I'm going to use the other method that I'll link here using x equals negative b over 2a. All right, try these out. You can get them. It just takes a little practice.